There we go. This style I'm not real crazy about. This was a generic form. This was about 10 bucks on Tandy. And there's another more popular brand that has the pins down here in a row. I think I prefer those, to be honest. Hey guys. Hey, Merry Christmas and Happy New Year to all of you. I was going to do a video about breathalyzers, and I got into the project and started learning about them. I've made one in the past, but I wanted to make a video about it, and I've never done that. And anyway, I learned about it. Then I went on the internet and I realized there's already great videos about a breathalyzer. Why am I redoing a video that somebody did a fine job on? So anyway, I thought instead I would just show you some of my struggles with the project, because this is stuff that I deal with every day, trying to make videos and different experiments. And this is the Arduino and the breathalyzer module. This is an alcohol sensor. It's an MQ3. But what I'm working on right now is the Arduino side with the breadboard and this LCD. So you can see I'm in the early stages of sending data to the screen. I'm just putting stuff up there to get the screen tuned in, and I think I'm good with that. I have that sorted out, but watch when I blow on the Arduino. Alright, something's not referenced to ground or something, because I don't even have the alcohol sensor on yet. It's here. This is just the circuit to power this. But I'm getting value through that pin. Why? That's just my breath. I'm not drunk. I didn't even drink any alcohol. This is my air. I think it's hot air because I turned this fan on. There's a little fan here. And, well, let me do it. Hold on. Isn't that odd? Anyway, I'm going to continue with the circuit, but I wanted to show you this. Normally you wouldn't see this, but I'm just thought I'd do something different than everybody else, because I've kind of lost interest in the project because it's already been done, and I'm just like that. I get excited because I think I'm doing something first, but then I discover someone else has already done it just fine, and there's really nothing else to be said. So anyway, I'm not going to stop. I'm going to go ahead and hook the alcohol sensor up and breathe into it with beer breath and stuff like that. So I'll be back. Applied Science YouTube channel has a good video on alcohol sensors. Go watch Ben's video. This is when I kind of lost my interest, because Ben does such a great job making videos. I feel like I learned something from him, so that's why I'm giving you the backside of this story. Just me making an alcohol sensor with an Arduino. I got a hot cup of coffee here. I'm going to take a drink and then blow on that circuit board. Goes up pretty fast. Isn't that a weird phenomena though? I think what it is I probably have a loose ground somewhere, and once I add the sensor it should straighten itself out. Anyway, these require like 5-volt steady voltage, and they really should be regulated so that you get a reasonably accurate reading back every time. They have a heater inside them. It actually starts up and preheats for like 60 seconds before you blow alcohol into this sensor. There's 6 pins on here, but you only need 3. You need ground, you need the signal, which will give you the number for the alcohol, and then you need the power to the heater. So that's 3. I wanted to show this circuit. This is something that my son Steve built. And he built this probably 3 or 4 years ago, and it's got that same sensor. Yep, he's got three wires. And he was lighting the segment display. It worked, I remember this. And this project of his inspired me to do this one. Then I found out that I should have done it a long time ago, because, you know, Ben beat me to the punch. Here's a schematic that somebody made. There's the reference. And here on this side of the Arduino is the connection for the sensor. Powering it on a 9-volt battery. Yeah, mine are MQ3s, and these are MQ2s. Okay, let's look up MQ3. MQ3, circuit voltage, heating voltage, AC or DC, resistive heater 33 ohm, less than 750 milliwatt. It's asking for 5 volts, plus or minus 1. So it's fairly picky. I'm going to see if I have a 5 volt regulator. Just a regular regulator. A regular one. 7805, isn't that a 5 volt regulator? Yep, they show the voltage going through the coil. So that doesn't matter. And then the sensors are on A or B, and it shows a resistive load on the B. I'll get back with you. The pins aren't spaced correctly to go on a breadboard. How dare they? I need a switch. And I'll just power this circuit separately from this circuit with the 9-volt battery. I'm going to test the heater in this first and see if it's working. It's not getting as hot as I thought it would. What's the specs say on that? I'm going to get this up on a stand and let it cook for a few minutes. Getting all scientific, aren't we? I'm going to have to jumper this open and just remember that I'm doing it. I think I can just use this clamp meter. You know, I never did get a straight answer on the operating temperature of this. I mean, I haven't dug real deep, but I don't see it on the data sheet handily. Why not? So really, this is a pretty low voltage device. So yeah, real close to 70. Yeah, the sheet itself says 20C, so we're right in that range. You can see it's maintaining right at 68.1 max. But that's real close to the tech specs. Actually, yeah, it's right on. So 68 degrees Fahrenheit, 20 Celsius inside the sensor at 5 volts constant, and it's been on for at least 5 minutes. Now I just have to hook the signal pin up to the Arduino and we can start reading measurements from this alcohol sensor. You can see this resistor right here, and it's a variable resistor. Let's look at the documentation that comes with that. So that resistor determines the sensitivity adjustment, and you can see the values there, so that you have approximately 200 parts per million. And I don't know much about alcohol content in that. I'm just following the directions basically. but I need to put resistance on the line so that the regular air without measuring is around 200, and that's after the heater's heated up. There's the pot there. Let's see if we can get it around 200 by turning our variable resistor. Okay, I've got it set around 200 for my parts per million. Let's see what the old alcohol pad will do. And don't look at this "you're drunk" thing. This is not calibrated yet. The only real number is this one. Okay, we'll let it settle down now and see if it goes back more quickly. It should settle back down to around 200. So yeah, it took a couple minutes for it to clear out, but it looks like it's going to settle back down at 200, so I think we're good on this. Now we just have to figure out what numbers mean what levels of blood alcohol. That could be the tricky part. But as far as I know, it's calibrated to the sheet now, around 220 parts per million. So what I'm going to do now is start from a cold start and see how long it takes for this to stabilize to 200, so I'll time it. Power on. It's climbing. We'll start the timer. And this will give us an idea of how long we have to wait before we can test our breath. And we can put a pause in our code. So we're just looking for around 200. You can see that took around 45 seconds or so. So a minute of warm-up time should be plenty. I'll go ahead and turn it back off and wait a few minutes and then try it again and see if it's still about the same 1 minute. So I'll do that off camera. Okay, I'm getting a little frustrated. I've been reading and you have to burn these in up to 48 hours to be consistent. And I'm verifying that because I set this exactly on 200 several times and it will drift, but I'm going to leave it on. Anyway, let me show you the documentation. This is frustrating to me. See, it says preheat time over 24 hours, and I was reading other places and they said 48, so who knows. And they give me all these statistics and curves, but there's really no easy way to change it to blood alcohol level because they're giving you parts per million. The problem is, how do you convert that over? Because not only do you have to have a reliable sample to calibrate to, but then you have to worry about outside variables such as humidity, which is a big one with your breath, and temperature, which is also your breath, and the room temperature to calibrate to start. So there are variables. If anybody knows how to write the equation to turn this to blood alcohol level, let me know. I'm coming to the conclusion that this cheap $5 sensor may not be able to be calibrated. The new sensors are metal enclosed and look like they have an environment, where this is just something to play around with. But I'm trying the best I can to calibrate it and get some sense of what the numbers are so I can calculate blood alcohol level. For me, I just really need to know the formula to convert these numbers to blood alcohol levels. But before I can do that, of course, I need to be calibrated in some fashion, unless this is normal to have such a swing. But I've yet to see anyone that could successfully calibrate this. And I think the reason why is because perhaps you can't, because it's too unstable. Here's what the newer modules look like. You can see they're on a little breakout board. It just went from 200 to 162, so I don't see this calibrating. I just don't. It's too unpredictable. So I think what I'm going to do is just leave this as a breadboard experiment and move on. I'll leave it on the breadboard for like a week after this video is published in case somebody has an idea, but don't have much hope for it. I'll just demonstrate this one more time. I have an alcohol pad here. Give it a sniff. You can see it jumps right up there. When I take it away, it goes back down. I just don't think the sensor is of high enough quality to build a project around it. I mean, you can already see the lengths I've gone just to get this working. The heater runs at a constant 150 milliamps. That's pretty consistent. I just don't think a 24-hour break-in is going to fix this thing. Maybe it's just too touchy. I don't know. If you have any experience with this sensor and the Arduino circuit, let me know. Okay, before I put this circuit to rest, I wanted to show you one more thing. I haven't been drinking any alcohol or had mouthwash in my mouth or anything, and I'm going to blow on this and you can see the difference just from the humidity and temperature difference. So you'd have to monitor at least those two things and then do some fancy calculations to make an algorithm to factor in all that stuff if you're going to do an accurate job. So I'm sure that's proprietary information from the companies that actually make these for a living. I don't think they're going to offer their equations to us. I don't know where I got this from, a retail chain. Here it is, Ollie's. $6. I've had this around for a while. Let's take a look at it and see what we get. Comes with these little tips. Just pop them off. Let's turn it on. Okay, we got a blow. Let me get you in for a tighter shot here. You can see a little speaker, piezo probably, on the back cover. And then the wires for the batteries. And it appears that they're in parallel. So it'd be a 3-volt system. And the sensor just sits up here, and when you breathe in here, it comes through this and then exits out these holes on the top. When this is back together, it has holes. There's actually a little labyrinth in there that the air has to go around. It doesn't directly blow into it. You can see it has to do the zigzag pattern through here. It just wants the overall ambience of the breath, and then it exits right out the top. So it's not being blown on directly at all. That probably helps with environmental variables such as wind. It may help with moisture content too. There's the switch. So this is nothing more than probably an Arduino. Let's take this out of here. Look at the circuit board. It's probably just a burn chip. Everything's put on that one little circuit board. Here's a close-up of that sensor. And they're just using 3 pins. So they have a ground, the heater, and the signal. I'm sober. That's correct. Now, let's drink some alcohol. And each person reacts differently to alcohol. which means that it's pretty much impossible to calibrate. Just use the numbers for fun. Just gives you an idea that if there's any alcohol present, it doesn't really mean to be accurate as far as showing you how much, because it can. It's just too simple. So this probably has as much accuracy as the one I'm building, but with a fancier programming package. In the end, it's just a toy though. Well, I hope you liked that little experimentation that we did. We learned a little something about blood alcohol and sensors and Arduinos. And hey, Happy New Year to you and your family. Thank you for watching. Leave us a comment. And we'll see you on the next one. See you next year. Bye for now.